Okay, welcome back. So now we've got our player, and we're able to make them move. But the next step that we need to do is actually make them look the other way when we move the other way. So you'll notice if we click this flip X under sprite renderer, it will actually flip our character. So what we're going to do is programmatically change this value in our code depending on our move input variable. And we're going to reference our sprite renderer in the exact same way that we were able to reference our rigid body 2D. So if we go back to our code, we can type in public sprite renderer. My typing is really bad, I'm sorry. I'm going to just call this sprite renderer. And then because it's attached to the same object as our script, we're able to do the exact same code. Sprite renderer equals, whoops. One day I'll get better at this. Sprite renderer equals get component, sprite renderer. Okay, and now we have access to it. And because Visual Studio is really awesome too, it knows now that our sprite renderer is of the class sprite renderer. So if we type it in and we type in dot, you can see all of its options pop up, and I bet flip X is one of them. So if you just do flip X equal to true, then it will flip it. Otherwise, you don't flip it. So this is going to be a little bit confusing, but if we do flip our character, they will be left. So flipping it makes it a negative value. Not flipping it makes it a positive value. So it's like the opposite of true. But that will make sense in a minute. So we're going to do something called an if statement. And if you haven't worked with those before, it's pretty simple. We just do if a value equals true, do something. Otherwise, do something else, which is basically what we're talking about doing right now. So we are going to create a variable up top so that we know, and it's going to be public, which value we're facing. So public bool facing right. And we are going to set it to true by default. Now, down here, we're going to say if move input equals 1, then facing right equals true. Else if move input equals -1, facing right equals false. So hopefully that makes sense. If we're moving to the right, which will be a +1, then we're facing right. If we're moving to the left, which is a -1, then we're not facing right. So this is a really good example of how Boolean works in a real scenario. And then we can just programmatically reference that flip X value on our sprite renderer variable now. So we can do sprite renderer dot flip X equals not facing right. And remember how I said it's sort of opposite? So if we are facing right and facing right is true, then flip X will equal not true or false. If I know that's so confusing, but it's basically saying this this exclamation mark it means not in programming terms. So if facing right is true, because we have the not in front of it, it will be false. So if we're facing right, then we don't want to flip our sprite. So we equal not facing right, which would be false. So that might be hard to wrap your mind around, but it should work now, I believe. So let's check it out in the editor. Okay, so it is working perfectly. Okay, so the next thing that we need to do is make our player jump, but we can't make our player jump unless we know if we're on the ground or not. Normally, when it comes to game development, this is actually a pretty big challenge, and a lot of things are a bit of a problem, but luckily I've already done all the solutions for you, so I will do my best to explain it. Basically, we need to know if the player is on the ground. So we need to know what the ground is. So for example, a player could land on an enemy or like a trap or something like that. And we don't necessarily want them to be able to jump off that because it's not the ground. So we have this thing over here called a layer. So for example, our player, the layer is default. We're going to add a layer and we're going to call it player. And then we're going to add another layer called ground. Now, if we click our player, we can set our layer to be player. So you might be thinking, just like the player, we want to set our ground's layer to be ground, but we actually have to change it up a little bit. You see, the way we're going to be doing this is if our player is touching the ground, then we want them to be able to jump. However, the reason why this gets a little bit complicated is because technically that would mean if our player got over here, can I just drag them? Right here, they would be touching the ground and therefore they would be able to jump. We only want them to be able to jump if they're up here. So what we're going to do is, you see how we have one big box collider in the parent? Instead, we're going to separate this into two different box colliders. One is going to be a tiny sliver of the ground, which will have the layer of ground. And the next one will be the rest of the ground that you can collide with, but you can't jump off of. So while something like that may be complicated to figure out, luckily, you guys have me here. So we're going to right click the ground parent object and we're going to say create empty. And we're going to rename this to ground. And then we're going to do that one more time. And we're going to name this to other collider. And then we're going to rename this top ground to be platform. Okay, so now we're going to get rid of this box collider on our platform. And then we're going to grab this ground and we're going to add a box collider to that. Then we're going to click edit and you're going to see it's way off for me. So I'm just going to drag it to be about like that. And then we're going to drag it in a little bit so they don't get caught on the side of the platform. And then we want it to be pretty small vertically. We don't want them to be able to wall jump. Unless, of course, you want them to be able to wall jump, in which case you would just make this bigger. So now we'll change this layer to be ground. So now in the future, once we're done coding all of this, our player will be able to jump off of this and it will detect this collider and say you can jump on it because its layer is ground. So now we're going to make another collider, but its layer won't be ground, so they won't be able to jump off of it. So to make this simple, we're going to right click our box collider 2D and we're going to click copy component. Then we're going to go down to other collider and we're going to right click our transform and click paste component as new. And then we're going to edit our other collider. And then we're going to bring our top one way down to where our bottom one is and then drag our, whoops, this is a little tricky to do, and then bring our bottom one all the way down to the ground. Okay, so now we have our ground collider, which we can jump off of, and the other collider, which we won't be able to jump off of, but it will still push us so that we can't go through the platform. So now what we're going to want to do is just make sure that everything's still okay. We always want to double check things as we go. Okay, so I'm still on the ground. Oh, and okay, so because I'm a rigid body, that means that I have physics, and if you run into the side of a wall, you will bounce off of it. However, we don't want to be able to rotate, so that's a really easy fix. We're going to go to Constraints under Rigid Body 2D, and we're going to click Freeze Rotation on the Z-axis. So now let's try that again. And we should just fall right to the bottom. Okay, so we are getting stuck on the side of this platform. And the reason why is because rigid bodies by default come with friction built into them. So you can imagine like a bug climbing up a wall. We don't want that friction on our player. So if we go back to our project and click our assets folder, we can right click and then click Create Physics Material 2D. And then we're just going to name this Player Material. And then we take our friction and we pop it right down to 0. And now if we go to our player, you'll see this material right here. If we drag our player material right onto that, then our player will now have 0 friction instead of the 0.4 friction. Let's try that again, and you can see we fall right to the bottom.